Hi, today we're going to talk about a problem that I don't have with my Daisy Hill Puppy Farms data mart, and that is accessing data out of a very large database, also a VLDB as it's commonly known. And Alteryx provides you with a way of dealing with this type of database and the association problems with it, and we're going to talk about those and solve them within this video. So what is the challenge of a very large database, a VLDB as is commonly known? And that is where you have a lot of data. Like for example, if you have a company with a million customers or 100,000 customers and the data warehouse has been around for 10 years and all that data is in the data warehouse and you just want last year's worth of data. Well, asking Alteryx to read 10 years worth of data into your workflow just is not going to work. As well as sometime, well, it would work, just have to wait a long time for it to happen. And that's all on your patience. Me, if it takes more than a minute or two to read my data, I'm sort of thinking there's a problem and I don't want to wait it out. Same thing happens with a SQL query. So if you're writing a SQL query to look at your data within a very large database, that query may take you 15, 20 minutes, or it might not work at all simply because it doesn't have the resources. And so what do you do with that? Well, first thing you do is you go and talk to your DBA or your database developer, and they say, oh, just don't bring all the data down, just query a piece of the data. But you say, but I need a year's worth of data, what do I do now? And then they just sort of shrug their shoulders and say, well, I guess you just have to wait for the query to run. I worked at one organization to where we had a very large database, and the analysts found out that they could run very large queries between 4 a.m. and 6 a.m. in the morning because the database had no throttles on it, as well as it wasn't very much happening, so they could run those very large queries. Anytime after 6 a.m., they couldn't run them anymore because the database was being throttled back again. But Alteryx allows you to do this dynamic incremental processing in order to solve this problem of getting your data out of your very large database. We're going to look at three solutions, and keep in mind that I'm giving a very simple solution for this problem because I've just really created one very large, not even very large, just one large table so you can see that there's a bunch of data, and then my query to get the data out there is very simple. But if you look at what's here and go behind the scenes, you can make this solution as sophisticated as you need it to be in order to get it to run incrementally. So the three solutions that I've used in the past, one is just simply using a dynamic input widget, which is a very simple way of getting the data out. If that doesn't necessarily do your problem or you have other things you need to do along with it, you can also surround this type of process inside of a macro that just uses a simple input data widget, not the dynamic one. So it gives you a little bit more control, better control, some more flexibility, potentially depending upon your need. And then the third thing is that even if your incremental data going through your input widgets is not efficient enough and you really need to look at building a more sophisticated workflow that's inside of the database using NDB widgets, I used a macro to do the same thing with an NDB widgets, and so therefore you could see how you can get more sophisticated along the way. So that being said, let's go ahead and take a look at what my data is, and I created this very simple workflow, and I will move this data set out into the shared source once this video is done so you can find it. And I created a table called the Puppy Hill Training Large Fact Table, which is simply right here. And all I'm doing is I've just put a years worth of data into it. The data is not real good. Again, I always recommend don't look at the details on my data because I just did a really rough methodology to create a year's worth of data that all looks pretty much the same. I ran this through, joined it with the date dimensions so that I could generate a year, month, number summary. And as you can see, the data is very, very consistent because it's just monthly copies, that there are 6,600 records for each month and a total of basically 80,000 records. Again, keep in mind, this is not a very large table. It is very small. And if you run this query in this workflow, you can see it runs through very efficiently, very quickly, because Alteryx can handle lots of data in a very efficient manner. But again, this is trying to give you a flavor for where we're going with this to deal with this in a larger nature, our assumption being that this is a very large database table, and we just simply cannot bring all this data down and process it. And so we will begin to build some incremental processes. So before we actually begin this incremental processing, we need to understand efficiently what the best incremental slices that we want to do within this data. While I want to look just at a couple months worth of data, that might not be the most efficient way to slice the data. It's just overall what I want to see. So when you're dealing with a very large database, you need to understand how the data for specific tables is being stored within the RDBMS and the most efficient pathway to get to that data. And that is what you want to build your query upon, or base your query upon. And so what I've done is take a look at my database, which is not my SQL database. And again, it's very small, and it's just simply for the exercise of how to go about and do this work. As I get all my windows put together here. So the table that I've created, that's larger than the rest of them. Again, it's not very large, but what I've done is make sure that there is an easy way to access this data in order to incrementally pull it, and that is that I have created an index. If you look here within the definition, you can see that this is highlighted in bold, which means that it is part of an index. We can verify this by stretching all this out. We don't need to see all the columns. We do, however, need to see the indexes. So here is my index, and you see that the column is the training date WID, which leads to this bolding of it. One of the things about the training date width, that was when I created the date dimension, it is a smart key, which means that it is the numerical value for the date, which makes it a very nice way to partition your data, a very nice way to query it, as well as if you understand that you can access into it. If you don't have something that quick and easy to get to, then you need to look at other ways to structure your query to make use of that index that goes into the very large table. So this is for my SQL database. If you're dealing with something like Teradata, which has very large databases all the time, which is why you buy and pay all the money for Teradata, then what you usually have is a primary index. It is an attribute that is used to determine how the data is stored and also determines the most efficient way to query that data. So then I would want to create my slices or my increments according to the attribute that is being used within the primary index, which is the storage mechanism. For very large databases that build in Oracle or MySQL, they tend to partition the data and have a partitioning key that determines where the data is stored. And again, that also indicates the most efficient way to get to that data, because you will get inclusive queries going against each of the partitions. So you want your index to pretty much match what your partitions might be, or at least be using the partitioning key. If you don't know how to find that information or don't know how to use that information, again, please talk to your database administrator, talk to your database developer so they can help explain to you how the data is stored and the most efficient methods to get to that data. But for our purposes, this index is not only what we would like to use, but is also what we need to use so everything works out fine. So our very basic query that I would use in this situation is selecting all the columns from our table and using a between clause for our indexed attribute, which is the training date WID. So this will return 1 month's worth of data and use that index to query it by. We execute that to make sure it works, and sure enough, there is our data. So that works good. It is what we want to base our access on within our Alteryx workflows. So we're going to turn this into the first of our interval or segment querying of data. And so let's go ahead and just, for understanding how this works, let's modify this to be that 1 month's worth of interval. 1 month interval of data based on date. So all that I want to do here is go into the table of query, and rather than just simply have the table name, what I want to put in there is the select query that we had used as our test example. We click test to make sure it all looks good, we didn't make any mistakes. And then we can run this 1 month's worth of data through. The query gives us no errors. and very quickly returns us that 1 month's worth of data. You go back to this and look, and you see this ran in 3.5 seconds. So it is obviously much faster not only to run the query but pull the data down, but it's not so much pulling the data down as it is running the query that we are concerned about making more efficient. So this query with this select statement embedded in it is going to be the basis for us incrementally accessing this data. So the first step that's common to all three of the solutions for incremental dynamic processing is to be able to create the increments and pass them into your process that will then run for each of the increments or ranges that you've provided to it. In our case, what we want to do is to process this data a month at a time. So let's build that piece of the workflow, and it involves 3 simple little steps. And we'll go ahead and cut and paste those in just so you don't have to watch me create them. We can talk about them. So first of all, either through, if you want to make this even more dynamic, through an interface or just simply into a text input, I want to do 6 months worth of data starting in 2021-03, which is March, and ending in 8, which is August. So I need to create a month interval for each month associated within this. The way we generate rows of data is to go ahead and use the generate rows here in preparation. Generate rows. If you're not familiar with this one, it's in some of my other workflows that we walk through, but it actually does a little looping process that either does or does not require input. In this case, we will take our data in for the start year month and the end year month, and we'll break that out into individual months using iterative process. Run through that very quickly, and you see that we start with just basically a beginning and ending, and for that beginning and ending you can see that here we have the end year month and the end month number. So starting with 03, going through 08, we create 3, 4, 5, 6, 7, and 8. That's great, but this isn't exactly the data that we need to pass into a process, because while this is great for a month, we don't want to have to do a conversion within the query. We want to instead give it the beginning of the month and the end of the month. That becomes a little tricky, but not exceptionally tricky, and you can always create a macro to do this for you as you need to, but it's just basically using your formula widget and creating some variables. I did this one step at a time so that you can see the process as you run through it and calculating those values. But you could also just simply do this with 2 formulas, one for creating each of the pieces of information that you need, which is the beginning of the month and the end of the month. But instead, like I said, I step through this one process at a time. So the first thing we want to do is we want to get a date. So we have a year month number, and we can actually create a date from that. As you can see here, it's the date time parse. We're going to turn that number into a string with no decimal places, and then use this formatting to create it with a year and month. And you see that that actually gives us the first day of the month by default, since it didn't have anything else. So we're happy with that. So this is the first of the month date. We need the end of the month date. And so that's easy. So this is actually sort of a trick in there, but it's the date time trim function. So we want to trim this date that we created and make it the last of the month. So a very quick and easy way to get to that last day of the month. Date trim, date time trim, give it a date within the month, and say you want the last of the month, and it'll give you a date of that month. This is great, but in order to process through dynamic processing, we can't have a date. We need to have a text string. And if you remember our query that we were using, which we can bring up very quickly, we can see that the format that we want to use within this query is 4-digit year, 2-digit month, 2-digit day. So we need to convert that date into that format and make it a character string so that it can be used as a replacement within the dynamic processing that we'll be doing. So all that we want to do here is to use the date-time format, which is another function, and it returns a string, and we give it the first of the month date, and we give it the coding of %Y, %M, %D for year, month, day. That's a 4-digit year. As you can see, that returns us a text string that's in the format that we need. And we do the same thing all over again for the end of the month, and that returns us the same information. So now when we run this through, you can see we have everything that we need to do this iterative processing with, which is one record for each month that's going to be in the iterative ranging. In the incremental pieces, we have the first of the month for the text and the end of the month for text, so that we actually can do our query with the between for those two parameters, making this a very efficient query. This will be the beginning of each of our 3 solutions, which are using dynamic input, a macro with input, and a macro within DB. The first and simplest solution is to go ahead and use the dynamic input widget. In the developer category, there are a number of widgets that allow you some programming functionality and are quite useful to make more complex or sophisticated workflows without having going to the trouble of building macros to do this work. In this case, we'll simply bring down the dynamic input widget, and we need to structure it and write in the coding pieces. The dynamic input widget will run once for each record that's passed into it. And so in this example, it will run 6 times as an input widget, combine the input into one workflow stream, and then you can post-process it afterwards. To create and configure this widget, we first click on Edit, which brings up a configuration, much like the input data configuration. So we'll click on MySQL. We'll paste in our query. We'll test the query. We'll continue with the configuration. Going to a database with the input data, I typically choose none for the SQL style, and I like to see the %complete. I just get used to doing that each time. Click OK. I now have the basic template for this query, and now we want to get into the customization. What I need to do is modify that SQL query. I'll choose Add, and I want to replace a specific string. The first part of this string that I need to edit is the beginning date of the range, or the beginning number for the range. And I want to use the first of month text. That way I know that there's no conversion issues. That's why I created this field, so that we can use it for each iteration of our query. It's been added into the processing. We want to add another replace specific string, so we can deal with the end of the between for the ID of the dates. And we want to use the end of month text. Get that clicked. So we have end of month text replacing the end of month stub. To validate this one, we come back here and we can click on edit so we can see as well. So this is the first of month text. So we validated that it does what we need it to do. We can then run this. And you can see in the log, it is actually showing us each individual query that is being run. So if there's any problems, we can visually double check them. Data looks good as far as I can see. So what we need to do now is to go ahead and go back to our initial workflow. We can just simply copy in all these pieces. And if we did things correctly, simply hooking them up will allow this workflow to run the same. So this dynamic input is run once for each record that's being passed into it. It modifies the range that's inside of the where clause. Take a look at the output, and we can see that the output matches expectations. So now we have successfully created a workflow that will read the months that we need, and running 1 month at a time, query the database with a very quick, simple query that is as efficient as we need it to be for the database that we're using, and then post-processes all those records into a final set of data that we can run our dashboard against. There's a couple of reasons why you might want to create a macro as opposed to using the dynamic input. The top two that come to mind are, one, if you want to do some additional post-processing of the data in a standard way so that you don't have to remember to do that each time. And the second is if you need to have a number of workflows that all need to do range queries against this data, and you have a couple people that are doing the same type of processing, and you don't want to have to remember how to configure the dynamic input each time, and you simply just want to call the macro that does the work for you. It simplifies your daily work. So to create the macro very quickly, we'll go ahead and pull down our input data. And what we're going to want to do is basically do the template the same way that we did the template within the dynamic input. Click on MySQL, paste in our query, test the query, click OK. We can run this to see that it works, which is always the recommendation before you begin to go into details in a macro. So it indeed works. We've replicated it sufficiently. We come into the interface category. We want to do our macro output. And we're going to want to have a couple of control parameters. First control parameter, make it nice English. Range, start date, and reminder that it needs to be text. Second control parameter, in case you're guessing along with me, we're going to want this be the range, end, date, text. And we'll need to take an action with each of these. This action then, each one individually, becomes the same as what we did in the dynamic input. Update value. Come into the query. Down here at the bottom, replace a specific string. We want that. We could actually just type this number in, but I always just like to make sure that I cut and paste, or basically cut out of it. So the range start date replaces 2021-0101. Put an action in the end date. Place a value within the query itself. Place that string as well. So then we have a very simple macro. Whoops. Connect those two together. Two parameters coming in, modify the query, and send that output through. Then all that we will need to do is to replace this dynamic input right here. And I already have this macro created, so I come into my macros, and it is my iterative. I'm getting way too many macros out there. I might want to organize these at some point in time. Iterative puppy training. Drop that in place there. Iterative puppy training input data macro. We want the first of month text to connect in, and the end to be the end of month text. Everything else looks good. We can run this. We now call our macro. We're not getting the same feedback here because I did not change that in the runtime. Just wanted to show you where it works default. Shows you that 6 iterations were run and our data coming out is the same. If you want to see each step, come into runtime, show all macro messages, hit run one more time, and you can see each of the individual queries running with the text for what it looks like when it executed up on the database. So that's how simple it is to replace that with a macro. So then our third and final solution for this problem would be to use the in-database structures so that this query can actually be written in an incremental fashion within your workflow and then executed on the RDBMS so that you use the power of the RDBMS server to do the work of joining information together. For our example, we really don't need to do this, but we just want to be able to show it simply, because a lot of times what happens when you're looking at a very large database, it's not just one table that you're joining together that is large, but multiple tables that are joined together to give you your solution set. To bring all that data down and do the join inside the Alteryx would be overpowering. So you would like to be able to do that work on the RDBMS to join 2 or 3 tables together to give you a reduced data set using all the proper where clauses and joins. Now you could write this query yourself. Me personally, when I would do this, I would write that complex query, test it through my SQL tool, and then plug it into my input data. If you're not comfortable with writing that kind of a query that's sophisticated and want to let Alteryx do it for you, then you can go ahead and head down the InDB pathway to do that heavy lifting. In this case, it is a simple query, so we just simply show you the fundamentals or the mechanics of doing that. We'll start again with a new workflow. This will become a macro so that we can very easily control the where clause. And by doing so, what we need to do is start with our connect in database. And to make this a little bit easier and more direct, I will go ahead and cut and paste what I've already worked on. And then just simply walk you through it. So here is basically the InDB query that we've been working with. We identify the table that we'll be querying from. We create an InDB filter. Keep in mind that this is indeed the where clause that is on the RDBMS. It must be structured in the language of your RDBMS. In this case, this is the textual context of the where clause in MySQL. It also is pretty much identical. For the same query to be in other RDBMSs is a common clause, but simply I have to type in or build that query in here. It is not as simple and straightforward, but it works. And then what I want to do is once that query is run, I want to go ahead and pull that data down into my stream so then I can post-process it. We click on run. And you can see that it goes ahead and pulls that 1 month of data that we've been working with. So then all I need to do is the same type of processing that I did for the input data macro, which is to come into my interface. I need my macro output. You notice that the connections between NDB are blue and the connections within native workflow are green. I must get the data down into a green connector to get into my macro output. And then all that I will need to do is to add add in my control parameters. Clicking them both on here. Repeating what we had done in the first work, which is the range start date. And put it in text as a reminder. Range end date as text. As you do a number of these, it does really become second nature for what it is that you're doing and how to connect all this together. Do my action. Oops. Wanted to show you this. My action goes into the where clause, which is the NDB filter. The action again is update value. We spread this out so you can actually see the where clause. Replace the specific string. So for the input, it's the 2021-0101. And then we simply repeat that with the second parameter and the action associated with it. Replace a specific string. So now we have two modifications being made to the clause that becomes the where clause through our filter. And then all that's left to do is to plug this in to our existing workflow. And again, I've already created this. You might have seen it when I was coming through here the last time. Give it a slightly different look. This is the iterative puppy training NDB macro. We want the first of the month text. We want the end of the month text. Let's try that one more time. First of the month text. End of the month text. There it is. Run this workflow. We don't get quite as good a feedback because it's an NDB, but you can see it's being run 6 times for our 6 months. And so now I'm doing my heavy lifting with the NDB widgets as opposed to a data input widget. So if I need something much more sophisticated, more complex, and I don't want to build a SQL myself, I can go ahead and use the MDB structures, create that into a macro, and then use this everywhere that I need to get a range of data out of my large table. Covered a lot of ground in this video. It was done fairly quickly because each of the individual pieces that we built together have been covered in other videos. So go ahead and check out the rest of the videos I have available for more details on some of these actions, where I will go much more slowly through each of these individual steps. But this was simply wrapping up some things that we've learned together into a more functional and usable and efficient set of workflows. As always, please subscribe to my channel so that you can see it as I release new ones. Drop me comments. Let me know whether you like those, what else you'd like to see, what else I could try to explain and get you moving forward in your usage of Alteryx. So have a great day.